This video is a very short review of coordinate systems, just so that you remember that there's more than one way to specify the location of a point in space. This is a set of axes in 2 dimensions. Most of the time, we think of them as being a y-axis in the vertical and an x-axis on the horizontal. And if I've got some point over here, it can be uniquely specified by its x and y coordinates, where x is the distance that away and y is the distance that away, right? This we all know. But there is another way to specify the location of this point uniquely. Well, uniquely in the sense that one set of coordinates maps only to that specific point. You'll see what I mean in a minute. There's another way I could specify the location of this point, though. If I draw an imaginary straight line from the origin to the point, and say that it has some length r, and the angle between that line and the x-axis is theta. If I give you r and theta, those also uniquely point to that particular place in my coordinate universe. So r and theta are called polar coordinates, and x and y are called Cartesian coordinates. Most of the time we use Cartesian coordinates, so much so that I forget sometimes that there's the other way. But polar coordinates give you the same information, and there are certain conditions where polar coordinates might be a more appropriate way of designating where things are in your system. Polar coordinates come in handy whenever you're talking, a lot of times if you're talking about trigonometric functions or things that cycle or anything where directionality is important. But mostly the only thing you really need to remember about polar coordinates to get through life successfully is to remember how to translate back and forth between Cartesian coordinates and polar coordinates, which is pretty easy if you remember the magic of right-angled triangles, right? Because if we look at our little triangle here, right, this is a right-angled triangle where r is the hypotenuse and y and x are the opposite and adjacent sides. So we can say that the cosine of theta is x over r, and sine of theta is y over r. So if I want to get from x and y to r and theta, well, r is the square root of x squared plus y squared by Pythagoras, which you remember, and theta is going to be, take your pick, inverse cosine of x over r, or you could use sine. Similarly, if you know the values for r and theta and you want to get x and y, x is equal to r cosine of theta, and y is equal to r times the sine of theta. And that's really all I want you to remember about polar coordinates.